Mrs. Traver here. Today we're going to talk about exponential expressions as well as some properties you can use when you're trying to simplify them. Our learning target is to be able to simplify expressions with the exponents, and you know you'll be successful when you can use the multiplication property as well as the division property to work out some problems and change them around so they look a lot more concise. Let's jump in and look at our first idea, which is some vocab. So it says an exponent is a shorthand for a repeated multiplication. By repeated multiplication, I mean like x to the fourth really means x times x times x times x. So there's 4 x's and they're all getting multiplied, and this is a long way to write it, so this is the shorthand version. What we call the x is the base, and 4 is the exponent. The whole thing makes an exponential expression. Let's try some of these ones where we're just asked to expand it. So I'm going to write this out the long way. I've got a 5 first and a 2 times m 3 times. So I have 2m 3 times. I can write it like this. That is the long way to write it. This time I have x cubed written twice. X cubed, x cubed. And this time I can write out 5 x's and 2 y's. So 4 times x times x times x times x times x and times y times y. So the long way. This one, matter of fact, I could go back and write this even longer. X, 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 x. We don't really need the multiplication dots because if we set variables next to each other, we need to multiply anyways. Moving forward, let's see if we can work on a multiplication property of exponents. So notice how these are written. If I expanded first, you might notice something that we can use. So if I expand x squared to be x times x, and then I expand x cubed to be x times x times x, I really just have 5 x's. So I could write x to the 5th. Do you see something going on here? X squared times x cubed. I mean x to the 2nd times x to the 3rd is x to the 5th. Really what happened here is that we just add the exponents. So if we think of it like that, then it'll make it a lot quicker. I could write this one out for the next one, 4 x's next to 5 x's next to 3 more, or I could think about how if I add 4 plus 5 plus 3, I get 12. So this is really x to the 12th. The next one, I would have had 3 n's and 5 n's, which really is 8 n's, so n to the 8th. This one, be careful on. How many m's are right here? What exponent goes on it? There's really just one of them. So you can think of one that doesn't have an exponent here as to the first. So this is m to the 7th. The next property is called power property. So when you have something that's in parentheses and there's a power on the outside. By the way, power is another name for exponent. So let's see what we can do with this one. Let's write it out the long way and see what happens. I would have had 2m times 2m times 2m. We're trying to simplify here, so I just expanded. Let me see if I can combine like terms with multiplication. I could rewrite this because multiplying you can do in any order, and I could write it as 2 times 2 times 2 times m times m times m. 2 times 2 is 4 times 2 again is 8, and m times m times m is m squared. I'm sorry, m cubed. Notice, another way I could have done this is distribute the cubed onto each of these terms, which would have been 2 cubed, m cubed. 2 cubed is 8, m cubed. That's a lot quicker way to do the same problem. So that's going to be the way we'll do it, is we distribute the cube, or the power, or the exponent, whatever you want to call it, onto each of the terms. So on this one, I only have one term, and when I distribute it in, it's going to multiply. Let's notice that on this one, when we expand, I'd have x to the 4th, whoops, just kidding. I'd have x squared, x squared, x squared, x squared. So I have 1, 2, 3, 4, 5, 6, 7, 8 of them, which really is x to the 2 times 4. So let's use that with the next one. When I distribute the 4 onto each of these guys, this was 3 to the 1st, now it's 3 to the 4th. This was k to the 20th, now it's k to the 20 times 4. Let's clean it up a little bit more. 3 to the 4th I can go off to the side and do 3 times 3 times 3 times 3. 3 times 3 is 9. This other 3 times 3 is 9, so that's 81. So 3 to the 4th is 81, And k to the 20 times 4 is 80. 81k to the 80th. Now on this one, I've got a cubed on the outside of a fraction bar. This cubed is going to get distributed onto the top and the bottom. So on the top I have x squared, and I'm cubing it as well, so I'm going to multiply. On the bottom I have y cubed. Cleaning up the top, I've got x to the 6th, wow, that was a really weird 6, over y to the 3rd. Let's see what's next. Division property. So these are all fractions now. And what I want you to notice is if I write this out the long way, on the top and the bottom, there's actually some canceling that can happen. The w's on top and bottom here and here can cancel, and I'm left with w on top. So I'm left with w cubed by itself, and there's nothing on the bottom, so I could put a 1 down there. Really, I don't even have to write the 1 on bottom at all. So my final answer here is w cubed. Notice, if you look back in the beginning of the problem, 5 and 2, if you subtract them, you get a 3. So the short way to do this is to say w to the 5 minus 2 equals 3. Let's do the next one, and let's use our trick. So first off, notice 10 over 2 is a 5 over 1. They can both get divided by 5, or by 2, I should say. Usually I think you'd probably write it like this. There we go. And then we know that we subtract these. So 30 minus 8 will be 22, and the leftovers are going to be on top. Since there's only a 1 on the bottom, I'm going to write it without the 1 at all. 5m to the 20. My pen is being really weird today. 5m to the 22nd. My next one, I noticed the numbers, 8 goes into each of these. 8 goes into 16 twice, and 8 once. And if I look at 3 minus 2, it's 1, so there's 1 extra w on top. So 2w with just a 1 on bottom, and then I'll rewrite without the 1 on bottom. Our next one, there's no numbers to cancel, so the 13 will stay up top. The p's, let's see, I had 2 extras on top, so 4 minus 2 is 2, so p squared on top. And the q's, I have 5 minus 2 is 3, so there's 3 extra on top. There's again nothing on bottom, so 13p squared q cubed. I'd like you to try some on your own. Go ahead and pause your screen and try these 4. Alright, I want to see how we did. On this one, we should have added the exponents to get y to the 7th. On this one, the w's can be combined. There were 4 plus 3 of them, as well as a p. So I would say w to the 7th p. On this one, 5 and 2 can get multiplied to get 10. And I had 1 plus 24 h's, so a total of 25 h's. And on this last one, I had 10 plus 12 x's, so I had 22 x's. All right, here's some more practice. This is our last slide. Again, freeze your screen and try these out. All right, let's see how we did. On this one, I had an x on top and nothing to cancel it with. And I had 6 extra y's on top. I don't even need the fraction bar really, so I'm going to get rid of that. The next one, I know 3 goes into 24 and 3. So if I divide by 24, if I divide 24 by 3, you get 8, and down here a 1. The h's are on top and bottom and they cancel. And I had 7 extra g's on bottom, so 8 over g to the 7th. On this one, 2 goes into 6 and 2, goes into 6 3 times, and 2 1 time. And the y's on top and bottom cancel. All I'm left with on top is 3x cubed, and the only thing on bottom is 1, so I'm not going to write it. On this one, I have a power property. I'm going to distribute that 4 to the top term and the bottom term, and when I do, I'm multiplying. So I've got m to the 3 times 4 over n to the 10 times 4. So I've got m to the 12 over n to the 40th. That's it for today, guys. I hope that the exponent properties have been treating you well. We're going to do some more practice as we move forward. I'll see you next time.